Welcome back to the HR Academy's channel, or welcome for the first time if you just fell into the maths side of YouTube, where things actually add up. Today, we're tackling trigonometry from grade 12 IEB past papers, because nothing says I love maths like sweating over identities and angles under pressure. So grab your calculator, sharpen your pencils, and let's decode some trig like the clever angles we are. Alright, let's jump into our first question straight from the November 2022 paper 2. It says, solve for theta where theta is in between 0 degrees and 360 degrees if cos 2 theta is equal to a half. Sounds serious, right? But don't worry, we've got this. First things first, treat 2 theta as your angle for now. We ask ourselves, when is cos angle equal to a half? So take your calculator and press Shift, cos, then put half. You should get 60. Since we're using 2 theta as our angle, we will use it to find theta. 2 theta is equal to 60 degrees. But we want angles between 0 degrees and 360 degrees. Which means there is probably more than one angle we are looking for. Let's look at outcast rule. Where is cos positive? Cos is positive in the first quadrant and the fourth quadrant. For the first quadrant, we use the angle we got, the 60 degrees. So 2 theta is equal to 60 degrees. For the fourth quadrant, we use 360 degrees, minus the angle we got, so it is 360 degrees, minus 60 degrees. And we get 300 degrees. Therefore 2 theta is equal to 300 degrees. Now divide both sides by 2 to get plain old theta. 60 degrees, divided by 2, is 30 degrees. 300 degrees, divided by 2, is 150 degrees. Therefore, theta is equal to 30 degrees, and theta is equal to 150 degrees. Simple, right? It's like cutting a cake in half, only this cake has angles instead of icing. And remember, we're not just guessing numbers that look cute. Cos 2 theta means your angle doubled, so if you rush, you'll end up outside the interval, like that one cousin who always shows up uninvited. Time for question 2. This one's from the 2021 final exam. It says, prove that 1 minus cos squared x over sine x is equal to sine x. Looks spicy, but it's actually just some identity drama. Let's break it down. Step 1. Recognize the identity. Remember our best friend in Trigland, sine squared x plus cos squared x is equal to 1. Now if you rearrange that, it becomes 1 minus cos squared x is equal to sine squared x. So we take that and swap the top of our original expression from the left-hand side. It becomes sine squared x over sine x. Step 2. Simplify. The easy way to simplify is to first make sine squared x sine x times sine x, which gives us sine x over sine x. Now since there's a sine x on both the numerator and denominator, they cancel each other out. And we are just left with sine x, which is the right-hand side. See? No need to panic, the identity just needed a little rearranging. Remember, always look out for those identity clues. Cos squared and sine squared like to sneak into disguises, but once you spot them, the rest is smooth sailing. Let's move on to a classic graph sketching question. Straight from the 2020 final paper. Sketch one full cycle of the graph. Y is equal to 2 sine 3x. Don't worry, it's just your regular sine wave, with a little too much energy, and a higher voice pitch. Y is equal to a sine b, x. The a represents the amplitude, and the b helps us find the period. In this case the amplitude would be 2. So your graph will bounce between +2 and -2, instead of the usual +1 and -1 from the y-axis. Tip. Think of amplitude as how loud the sine wave is screaming. In this case, it's got a megaphone. For the period, we use the formula 360 degrees over b. In this case, b is equal to 3. Therefore, the period is 360 degrees over 3, which gives us 120 degrees. So this function squeezes the entire sine wave into just 120 degrees. One full cycle would be from 0 degrees to 120 degrees. A standard sine wave is divided into 4 parts of the cycle. Let's divide 120 degrees by 4. It is 30 degrees. Each part of the cycle has a 30-degree difference. Sine graphs usually start at 0. Since each part has a 30-degree difference, we need to take note of each part. The mark points would be 0 degrees, 30 degrees, 60 degrees, 90 degrees, and 120 degrees. And we now have our graph. Just remember these three things when sketching any trig graph: amplitude, period, and shape. The rest is smooth curves and cool maths. Alright mathletes, time to dive into another trig equation. This one's from the 2022 Prelim paper, and it goes like this. Solve x where x is in between 0 degrees and 2 pi. 2 sine x plus 1 is equal to 0. Step 1. Isolate sine x. To isolate it, we need to subtract each side with 1, and we get 2 sine x is equal to minus 1. Now, we need to divide each side by 2, and we get sine x is equal to negative a half. Step 2. Think CAS diagram. Now let's figure out where sine is negative. Sine is negative in the third quadrant and the fourth quadrant. We are working in terms of pi. We know that 180 degrees is equal to pi, so let's look for the value of x. To find x, put shift, sine negative a half on your calculator. You should get negative 30. We need to find what negative 30 degrees is equivalent to, in terms of pi. To get that, we say 180 degrees divided by 30 degrees, which is equal to 6. Since x equals minus 30 degrees and 180 degrees equals to pi, 30 degrees is equal to pi over 6. Remember that sine is negative in quadrant 3 and 4. For quadrant 4 we should say 2 pi minus the angle we got, pi over 6, which gives us 11 pi over 6. And for quadrant 3 we should say pi plus the angle we got, pi over 6, which gives us 7 pi over 6. And our final answer is x is equal to 11 pi over 6 and 7 pi over 6. So remember, isolate, use your cast, find your reference angle, and boom, 2 neat solutions. Trig really just wants to be understood. Like your playlist during exams. And just like that, we've tackled some of the trickiest trig questions from past exams, with a little laughter along the way, of course. If you're feeling more confident now, that's a win. But if sine, cosine, and their sneaky cousins still have you confused, don't worry, part 2 is on the way. So don't forget to like this video if it helped, subscribe so you don't miss part 2, and drop a comment below with a topic or question you'd love to see explained next. See you in part 2.